You're listening to the TahoeDeep Podcast, hosted by Chase Petley and Noah Jeremy.
He said, Donnie, there's things out in this lake that nobody has ever seen.
It's impossible to see clearly or identify what kind of fish it is. Fish researchers said while the animal looks remarkably shark-like,
we found a large fish while we were videotaping at 1,100 feet.
Petley is hoping to expand and refine his project.
In 1976, I was out on Lake Tahoe, and we saw something that I cannot explain.
Hi, everyone, and welcome to another episode of the TahoeDeep Podcast. I am Noah Jeremy. I'm here with Chase Petley, the man, the myth, the legend. And today we're going to talk about ROVs, some of the things that Chase has built to explore Lake Tahoe, some of the things he is currently building, and why he is doing it and why he seems to be the only one doing it. So why don't we start there, Chase? Why are you the only one that is doing this and exploring the bottom of Lake Tahoe?
Well, in the beginning, there was a void of any pictures at the bottom of Lake Tahoe. I used to work in Nevada, and I live in California, so I would drive over the mountain every time to go to work. And through seeing the lake so much, I wanted to see what the bottom of it looked like, and no pictures existed. So I thought, this can't be that hard of a problem. I'm going to tackle it. I'm going to get the first pictures of the absolute bottom of Lake Tahoe. So that started me off on this journey where I did lots of research engineering. I did lots of pencil drawings that evolved into wood drawings, which I later brought to engineering firms where I worked. And we built these things.
And this picture you have up on the screen, that is the first thing you built to go to the bottom of Lake Tahoe, right?
Yeah, that is a 21-year-old Chase Petley there. And we're doing kind of like a cool artistic photo of it with a white background. And that was essentially like a glorified drop cam that combined 5 cameras into a massive panoramic vision, like a 360-degree view there. And each one of them had their own independent lights. So how this came about was I had an idea to be the first person to see the bottom of Lake Tahoe, and I had to do it in a logical way. So I wasn't going to try to build a complicated ROV or anything. I figured if we get a camera down there at 1 atmosphere, essentially meaning the pressure is not exerted on the camera itself, and a light, right, we can be the first people to videotape the bottom of Lake Tahoe. So this ended up being kind of overcomplicated way to do it. But you can see its form. It's pretty simple. You drop it down the bottom and you get a view of Lake Tahoe. So that was the first thing that we built, and that was the actual picture that resulted from that little day.
And it was called TahoeDeep, which is funny because that's what this organization is called now.
Yep. I've moved through several iterations
because I didn't. Yeah. So let's just talk about why is it so difficult? Lake Tahoe, 1,600 plus feet deep. Why is it so difficult to get a camera down to see something at depth? Why couldn't I just take a GoPro in a waterproof case and 1,600 feet of cable or rope and drop it down and see the bottom?
Well, you're dealing with a lot of pressure in Lake Tahoe, as long as some other factors as well. To start off, the easiest mitigated one is the cold. Batteries don't like cold. They're not going to last long. It's a long trip up and down. The second factor that you're dealing with is pressure. At 1,645 feet, you're dealing with about 742 pounds per square inch. So that's essentially a horse standing on one leg on every inch of your object that you're trying to drop down there. So you would find that a GoPro in one of the cool bulky housings like they used to have during the Hero 3, that was the deepest diving GoPro, but that would smash at about 220 feet. So we had to build something that was 3/4 inch aluminum and polycarbonate glass that would resist the pressures of Lake Tahoe. Another one of the huge factors that stopped more complicated projects that had some more money behind them was the currents in Lake Tahoe. If you're transmitting video up that far of a distance, you have fiber optics. And fiber optics are not very forgiving of twisting. You twist a fiber optic a few times and it snaps. And that's what happened to my competitors at the time. They put a multi-million-dollar ROV 500 feet in Lake Tahoe, lost telemetry, and almost lost the whole thing. So that's why I was able to move in and get the first pictures of the bottom of Lake Tahoe.
Right. So is it possible to get live view feeds in a deep lake like Lake Tahoe without using fiber optic cables?
So previously, I experimented with Cat6 cables because they're much more forgiving of the twisting. So I figured out through Ballums that I can transfer a video footage over great distances of length, much more than people think online, by using Ballums, a balance-unbalanced signal rectifier, and balancing the ground. So I'm now capable of getting video much deeper, and it's a live view, which you can see up on the screen in okay quality. We're not talking about 4K, but we have 720p with quite a good sensor that can see in the dark. So it's also instantaneous, there's no lag. So you'll be able to traverse through objects and move the ROVs, which I'm going to talk about later, through the use of that kind of technology. In the future, if we can mitigate spinning through controls, we could upgrade to fiber optics and have 4K on the top. But what I'm thinking about doing to keep it simple, because we still have a goal to do right now, is to do a low-quality video feed live and store on board the 5.1K video that we plan on taking in the future.
So essentially we'd have some like GoPro cameras or even higher quality cameras that we turn on before we drop it. They're in a safe, depth, pressure-proof housing. Those, we can't see the footage from those cameras, but they're going to go down and film at the bottom of the lake and do their thing. Meanwhile, we're going to have a lower quality live view we use to navigate, and then when we bring it back up, we would use that to look at the high quality footage from those other cameras. Is that correct?
Yeah, you're correct. Yeah, absolutely. Just a little other things. We're looking at taking off infrared and UV coatings on lenses, doing little experiments because cameras are not developed to be filming underwater. We're going to look through filters like IR filters and things like that to see what's the best quality footage we can get underwater. Because Lake Tahoe is kind of a unique situation where you can see 100 feet in water from the surface. So they measure the clarity at 100 feet. But what you also have to think about is that they're seeing the light that goes 100 feet down and bouncing 100 feet up. So I think potentially with the correct lighting and the correct cameras, you could see up to 200 feet in Lake Tahoe because it is 99.9997, I think, percent pure, the water.
Yeah, and why that's important is once you get down to an insane depth, like 1,600 plus feet, it is pitch black. It is black, the blackest black you've ever seen in your life, and the only way you're going to see anything is with a high-powered light. And so that's one of the limitations is we've only really been testing with low-power lights, but we had some successful tests. We couldn't see very far, but because they were successful the way we were protecting the lights, now we can up the quality with some more expensive lights that can see further and really light up the port
I won't say exactly how we're doing it, but we've actually we've formulated a way to build low-cost, extremely high-power lights that don't cost thousands of dollars in machine products. So I have tested those up to 6,000 feet in my day job, and I think we're going to be using those in Lake Tahoe and doing further testing. So also on screen right now we have a picture that was taken from the very first drop that's seen the bottom of Lake Tahoe. These are the first images ever brought back from the bottom of Lake Tahoe. And in the very first image, we seen a shrimp. Actually, we seen thousands of shrimp. So that kind of blew the doors off of me thinking that there might not be that much life down there.
Now, to be fair, these are mysis shrimp, which are invasive. So while there's tons of life down now, tons of shrimp everywhere at the bottom of Lake Tahoe, we don't know that before these were introduced that there was that much biomass down there. That being said, invasive species tend to replace and outcompete native species. So maybe there was a large biomass of a different type of shrimp or other wildlife down there, other, small crustaceans that was been outcompeted and replaced by these invasive mysis shrimp. But the point being, there's a lot of life down there now. That doesn't necessarily mean there was a lot of life down there in the past, because what we're seeing in these pictures are an invasive species. Sure. So you built this camera housing that was able to withstand depth. How did you learn to do that?
Well, the first one I designed on paper, and then through my next learning and jobs and doing some college online, I learned computer-assisted design. So what I'm showing now is actually, I used to build car parts. And this is a BMW car part that I made. So it's kind of example of CAD. And I'll show you more later. But that's what I was doing for a living. And the only reason I did this job is so I could learn computer-assisted design, so I could build things to go to the bottom of Lake Tahoe.
Playing the long game.
Hey, I later on went to work at a machine shop. It was very low pay, and I did it almost like on a volunteer basis. But to be able to get access to the machines and to learn what the machines can do, you really got to work there. It's not something, I think it's really something engineers lack, is they don't work in a machine shop. So they're asking the machines to do far off things that the machines can't do. So I learned about materials and stock materials and things like that, and what kind of operations I can program into the computer-assisted design to build these things cheaper and easier. And that was one of my other goals, was making them not just to explore the bottom of Lake Tahoe, but making them cheap enough and simple enough so we could give them to as many people as we could.
Mm-hmm. And this is a picture on screen of the camera housing you machined, is that right?
Yeah, so keeping trend with making things cheaper and simpler, this was a prototype I made that held a camera and a light. It had two separate compartments. So this was made out of a stock block of aluminum. It was only machined in, I think, 2 operations. And I designed this to be part of the rocket device that went down to the bottom of Lake Tahoe when I was on Case Area 3. I wanted it to be streamlined and have one single piece of polycarbonate to work for both housings. So this was the next iteration that evolved on the business TahoeDeep little journey. And this was a picture here of the prints that you have to make for a machine shop to build things. And these are some of the parts right when they came hot off the machine.
And this reminds me of a story when we went out over the summer. Actually, it was the beginning of September, which may still be summer. I don't know when fall starts. But we went out on kayaks in Lake Tahoe, and we were going to test out a C-Lab you'd made. And we get out there, and we pull this housing, and you're attaching it to the main C-Lab you've put together, and we didn't have any Allen key to be able to turn the screws. So essentially, it's 2 parts. It's the main casing, and then it's kind of got an part aluminum, part glass covering that is held to the main casing with screws. And the problem is we didn't have any Allen keys to be able to tighten them enough. So you were trying to figure out how to tighten them with whatever you had on hand, and we spent about, I want to say 40 minutes searching, just asking everybody on the beach for an Allen key until someone finally gave us just big enough that we could kind of make it turn, and by we I mean you, but not efficiently. And so one of the housings filled up with water, but thankfully it wasn't the one that we had the GoPro in.
Yeah, that was fun. I remember this is the camera housing we used that day, isn't it? I don't usually use this one anymore. I guess it's the last time I've used it. But I remember running up to the parking lot at the beach and asking people, "Do you have a 2.5 millimeter Allen key?" And everyone looked like, I'm like, "Why would I have that?" And then I had to explain too. They're like, "What do you need it for?" And I was like, "Well, we're about to film at the bottom of Lake Tahoe, and I need to tighten this thing down." And then I had to tell the story. The whole story. They're like, "What do you mean you're going to film
like
at the bottom of Lake Tahoe?" It's like, "Well, I have this aluminum housing. It's got the stuff on it. I need to tighten it down so we can video. We're going to go out there in kayaks. This is what we're doing." And eventually some people that were surfers were like, "Hey, I got something pretty close in my bag," and gave us a key. And it was like I think it was a 2 millimeter key or something in standard, but it ended up working almost good enough.
I remember it's kind of like when you have a screwdriver that's just too small, and so you yank it on an angle a little bit to be able to get enough leverage to turn it. That's what happened. I think you got an email there.
Oh, shit. That popped up. Okay, so everyone got my email. That's cool. It's about a future podcast anyway, so.
So you've talked a bit about the challenges of getting something down there. So all combined, people aren't exploring the bottom of the lake because... would you say most of the commercially accessible ROVs people can get just aren't capable of going deep because there's no need for it? And there's just not enough customers that want to go down 1,600 feet. So most of the ROVs you can buy are only really rated to go down about 300 feet. Is that fair to say?
Well, there's a
and
big
even
gap.
those, yeah.
Yeah, there's a big gap in the capabilities of ROVs and cost. So, for a reasonable price, and when I say reasonable, maybe $10,000, you can go and pick up an ROV and customize it a little bit to go 300, 400, maybe even 500 feet deep these days. But the amount of money you're spending to look at that depth really, I don't know, in my personal opinion, wasn't worth it. And then there's a huge gap where you go into the multi-million dollars. You have ROVs that can go thousands of feet deep. But not only is the cost prohibitive, they're about the size of my whole office here. And it's the ones I use at work. I use work-class ROVs. They can go 10,000 feet deep. But the winch alone that puts these things in the water weigh more than about 5 of your average boats on Lake Tahoe. You wouldn't be able to fit these things down the highway to get to Lake Tahoe. You're talking multi-million dollars, just big control rooms and a whole crew. I think,
And a big boat.
Yeah, I mean, honestly, if you can find a barge to put a work-class ROV on in Lake Tahoe, you'd still be looking at about $30 million cost to make that thing actually go in Lake Tahoe. So
Yeah.
I knew that wasn't going to happen. So that's when I started developing. This is on my screen here. You have the first ROV that I designed. It was essentially utilizing components from a drone. I was thinking about using Blue Robotics thrusters, using my existing camera housings, but still at this point, I didn't have the live view camera made. So even with the complications I had figured out at the time, it still wasn't something that was quite doable. That's why I designed the live view camera. The live view camera was what I used with the Ballums and the Sony 720 TVL cameras, and that's what I was able to see live view for the first time. Right after I got done designing these, I actually got called out by a family whose son went missing out in Kentucky. And through a lawyer, law enforcement, and them, I was able to go work on this project doing body recovery. So this was a trial by fire for this camera housing. I used it in a lake that I think went up to 250 feet deep, and it was a reservoir-made lake. So it used to be a valley that got flooded by making a dam. And there was standing oak trees and lots of obstacles in the way because this valley flooded and they actually lost equipment like bulldozers down there. So it was like navigating through a whole forest. And I know the law enforcement, I want to say FBI, went out there with their cameras and lost several cameras trying to do it. But I was able to operate for over 110 hours in a span of 21 days, and this thing didn't break once. It didn't have a leak, and I was pretty confident in how well it was going to work. So at this point, I had my live view camera, and making an ROV was possible. So worked on the design, and I wanted to make it. I wanted to make this affordable and doable for anybody. And the biggest thing about exploring in deep water is really the boat and the control stand that you're going to have. The ROV is one cost, but to put down an actual ROV, you need a massive boat. So what you see here is 3 iterations of the same product, because I envision people buying the first one, being able to upgrade to the second one, and then being able to upgrade to the third one. And the first one is a camera and light combination. The second one is a camera and light combination, but separated with 2 different housings. And the third one, you still utilize what you bought before, but it's the whole drone that you can fly. So this is an idea, a direction I was heading in, that I never really quite made it there, because by that time, I learned enough while working on ROVs, I decided I wanted to track ROV.
Yeah. And why... So I want to talk about what makes a tracked ROV in your mind better than this, but before, better than like a... And just for those listening, like a hovering ROV that uses propellers. Think about a quadcopter, like a drone, but it's underwater. That's kind of what this picture is. So I want to ask you, and I'll come back to this, why you prefer tracked over the drone propeller style. But before we get to that, I want to go back to the body recovery story, because that's just very interesting, and talk about that a little bit more. So,
I don't think I can talk too much about it, but
did you end up
finding
anything? Did you end up finding anything body related? Can you talk about that?
That part of it I probably can't talk about.
Okay. And I remember, and maybe I have to cut this out, but you said that there was some sort of threats going on local?
Yeah, actually. There was some divers, I believe Rex Law Enforcement or something, at least they posed to be, that actually threatened me when I was out looking for the body. It wasn't a direct threat, but they mentioned, hey, you're out there all alone, you know, and then they were bragging about their guns and stuff and talked about how long it would take them to get there. So I reported that to the
So
people I
these
was
were
working
law
with.
enforcement, ex-law enforcement, current or
Supposed,
previous law, or you don't know?
They were supposed ex-law enforcement. They're also supposed ex-military, but me being military myself, hearing what they had to say about the military didn't really quite add up.
It was more like people pretending to be part of the military to scare you, but they didn't really know what
I
they were
think
talking
these people,
about.
they also claimed to take part of like the raid that killed Saddam Hussein. Like they're crazy, and that's what kind of made me worried about it in the first place. Like they were nuts.
Some muscle men sent to intimidate you a little bit.
Yeah, they thought they were pretty cool. But I was out there just volunteering, trying to help this family. And to this day, I still have a soft spot in my heart for this family because they're great people.
Yeah, and that's very sad. And, you know, as a father,
can't imagine.
you're a father as well.
Yeah, I mean, losing my kid's one thing, but not being able to find out what happened in those last days or hours, is, you know, that's pretty nuts. So
It's a nightmare material. So moving on from that, that's a crazy story, and maybe we'll come back to that in another podcast. Or maybe we'll just talk about deep water body recovery in general, because there are
there's
stories
lots
of
of
body
deep water-
recovery in Tahoe.
yeah, we can have some really cool people on that have done some cool body recoveries, which are personal friends of mine in Lake Tahoe. The most famous body recoveries in Lake Tahoe, my personal friends have done, so I'd like to talk about that, and the ones I've taken part in.
Including one that was a diver that was lost in Lake Tahoe 17 years ago and was recovered perfectly preserved. Were they involved in that?
Yeah, so it wasn't. He was underwater for 17 years, and when he was brought to the surface, his face was still identifiable to the family. He was so well preserved. So
Yeah.
I have divers that will probably maybe being able to, if they can talk about it. So,
Great.
but they're really
So-
close friends of mine. So.
Yeah. So let's go back to that other question I wanted to ask. The current picture on the screen.
Yeah.
You had this quadcopter underwater ROV design that you never got to because you decided a tracked ROV would be more ideal. Why do you think
Yeah.
that?
Well, there's a couple of reasons. So this ROV is small, and it'd be great for somebody exploring maybe 600-700 feet deep. I built it to take the pressure. The parts were tested far below that pressure. Most of these parts I brought out to 7,700 feet deep in the ocean and tested. The problem is when you get to that small of an ROV and it's floating, it cannot pull 1,600 feet of cord. You got a lot of coefficient drag behind it. So there's almost like a gray zone in between how big you can make an ROV. You can either make it really big and heavy and powerful, or you can make it light and small, but it can't go that deep because no matter what, you're always going to be fighting the fact that you got to transmit power through a cord. There's no known
Right.
technology that can transmit wirelessly through water. There's acoustic relays that can
That was
transmit.
my next.
Yeah. Underwater, you can transmit acoustic relays. And essentially, what you would have is different devices every couple hundred feet that are transmitting, rebroadcasting a signal. But it's only really reliable for audio, sonar, that kind of thing. As far as getting images, never mind HD images, it's not done yet. There's a company in the UK that's working on it, but they're still not even close. So I think corded ROVs are the future.
Well, and just to interrupt, they're certainly more practical. You know, we're talking about a future technology if we're going to get into wireless ROV operation. But just to talk about what you mentioned about the acoustic, using acoustics, I do know that Victor Vescovo, who is famous for diving to the deepest parts of 5 oceans, including the Challenger Deep, that's what he used to talk with the ship when he was down at the bottom of the ocean, was a kind of acoustic relay, I believe. And it was very, very unreliable, and there were multiple times where he just lost contact. Either he could hear them and they couldn't hear him, or vice versa, or there was just no transmission going through. So just the unreliability of it makes it pretty far out and unpractical, because even if there's a technology that develops figuring out how to use that for video purposes, it's going to be unreliable, especially with all of the noise in a busy lake like Tahoe, filled with people with their fish finders and who knows what, you know.
Yeah. Victor Vescova, what a badass, eh?